Okay, stats. I'm going to go through the last little bit. We're not going to do every example for section 4.3, but I have a couple of them that I want to go through in particular because I'm only going to give you these 3 problems for homework, which is enough. I mean, like, there's several steps that you have to do on each one of them. I'm just trying to feed Navy a bottle here, so sorry if we end up... Yep. All right, so... Okay, so 220 and 34, those are the problems that I want you to do for 4.3, page 201. There's, like, it lists the asymptotes, lists the points of inflection, lists the maximums and minimums. So we're going to go through just the examples that are similar to the ones that I'm going to give you for homework. We're just going to do those examples on the notes here and then call it good for section 4.3. So I'm going to go through example 2 with you. I think you have one like that on your homework assignment, but this is the equation that we have. It's a rational function, but it's like a polynomial on the top and then it's a polynomial on the bottom. So like no square roots or anything like that. No log functions, no trig functions. We'll get to those down below, but this one is sketch the graph of this guy. So first things first, it says list all asymptotes that you have. So we have Vos and then we have Haas. And we wrote down, I don't know, it was like on Friday or something, how you find each one. Okay, so we list them here. For your asymptotes, for the Vos, you set the denominator equal to 0. For your Haas, you're looking for that N and M type thing. Okay, so let's do the Va first. Okay, if we set the denominator x cubed equal to 0, right, we take the cubic root, and the cubic root of 0 is just going to be 0. So I'm going to have a Va at 0, okay? I went ahead and gave you the answer, what the equation looks like, just so that we can start to compare. And we have our Va at 0. So this is what we've just found. Our vertical asymptotes at 0. Great. Okay, now we got to do the Ha. Okay, and to find the Ha, the N and M. Okay, N is the degree of the numerator, so that's 2. And M is the degree of the denominator, which is 3. Okay, and because he's bottom heavy, right, like the bottom is bigger, he is going to just sit at 0. So y equals 0 is going to be the Ha. Okay, the horizontal one, you're just going to sit at 0. If he was top heavy, you'd fall over and he wouldn't have a Ha, right? If they were equal to each other, then you would look at the leading coefficients out in front, but that's not the case here. So we have y equals 0 is going to be your horizontal one. And let's see if that compares to the graph. He looks like that right there, okay? Yeah. What do you think? What do you think? All right, so there's my horizontal asymptote and my vertical asymptote, okay? Then they want us to find intercepts. Okay, so to find the x, I'm going to list them here. To find the x-intercepts, we plug 0 in for y. Okay, great. So if I do that, 0 is equal to, I've got x squared minus 1 over x to the third, okay? All right, then I've got to solve for x. So what I'm going to do is I'm going to multiply the x cubed over to get him to go away, x cubed. All right, so then 0 times anything is 0, and we've got 0 equals x squared minus 1. Great. Then I'm going to add the 1 over, so 1 equals x squared, and then if I take the square root, I end up with plus minus 1 is what my x-intercepts are. Okay, let's see if that is good with the graph. He touches the x-axis at plus minus 1. Great. All right, now, just cheating and looking at the graph here, I can see that there are no y-intercepts because the vertical asymptote is the y-axis. So let's see if that is consistent with what we have going on here. All right, to find the y-intercepts, I'm going to plug 0 in for x, okay? So I've got y equals 0 squared minus 1 over 0 to the third power, okay? And you can kind of see how this works. 0 squared minus 1, this is going to be negative 1 over 0. And you cannot divide by 0, so that is why we end up with no solutions for y-intercepts, okay? Also because there's a vertical asymptote there. So those two things are consistent with one another, all right? Then the next thing that we want is relative extrema. So we want like maxes and mins. So we're going to have to do the first derivative, and then we're going to have to do the second derivative. Okay, so we'll see how ugly this turns out. We'll see. All right, so, sister, what are you doing here? There. Hold on just a second. Let's get you something to play with. There. Okay, so let's do first derivative here. And so we have to do the quotient rule. y prime equals, quotient rule, f prime g minus g prime f all over g squared. Okay, so f prime is the derivative of the top. That would be just 2x. So I'm going to put 2x here, and g is going to be x cubed. Great. Minus g prime is the derivative of the bottom, which is 3x squared times x squared minus 1. Perfect. Perfect. Okay. On the bottom, g squared, we've got x cubed and then squared. All right, so if we do some simplifying, this guy right here is going to be 2x to the 4th power minus, if I distribute that through, that's 3x to the 4th power. And then it will be plus 3x squared, okay, because the minus goes with the 3x squared. So if I put that all together, these two chunks go together. That is negative x to the 4th plus 3x squared and all over x to the 6th power. Whew, that's disgusting. Okay. All right. Now, let's see what we got. We got to set that equal to 0 to find our critical numbers. And the bottom's going to go over and drop off. So like times x to the 6th power, he's going to go away, right? So I have negative x to the 4th plus 3x squared. He is equal to 0 because the bottom's gone. And then I'm going to take out a negative x squared, okay? And left over will be x squared minus 3, I think. Yeah, x squared minus 3. Oh my gosh, this is disgusting. Okay, negative x squared equals 0 and x squared minus 3 equals 0. Okay, here we go. If I divide by a negative and take the square root, x equals 0. He is one of my critical numbers. And then if I add the 3 over, I'll get x squared equals 3. And I'm going to take the square root. And that will just be plus minus the square root of 3. So I have 3 critical numbers there. Blech. That's disgusting. Yeah. Shall we do the second derivative? Yeah, sure. Let's do it. Let's try. Why not? Okay, second derivative. So derivative of this guy, we got to do another quotient rule. Okay, so y double prime. Here we go. Buckle in. F prime g minus g prime f all over g squared. All right, g squared is this guy, like x to the 6th and then squared again, which will be x to the 12th power. All right, I'm doing a little bit of simplifying. All right, f prime is the derivative of the top, so negative 4x cubed plus 6x times g, which is x to the 6th. Holy crap. Minus g prime is 6x to the 5th. And then times f is this stuff. Blah. All right. Here we go. Let's distribute that through. So we've got negative 4x to the 9th power plus 6x to the 7th power. All right. Now we got to do this. And keep in mind that that's a negative 6x to the 5th. So that will be plus 6x to the 9th minus 18x to the 7th. Okay, that's not terrible. We can manage that. That'll be okay. I think I did that right. Yep. All over x to the 12th power. Okay, we really don't care about this guy down here because when we set it equal to 0, he's going to drop off again. All right, so stay with me here. We've got these two added together is 2x to the 9th. These two added together is negative 12x to the 7th, all over x to the 12th. Okay, equal to 0. This is, again, my second derivative. This is for my points of inflection, okay? So I'm going to take out, the bottom's going to cancel off whatever, right? 2x to the 9th minus 12x to the 7th. If I set that equal to 0, I'm going to take out a 2x to the 7th power. So I get x squared minus 6. Left over, I think. Yeah. Yeah, let's go with that. All right, equals 0. 2x to the 7th equals 0, and x squared minus 6 equals 0. All right, if we divide by 2, and take the 7th root, we get 0. Okay, if I add the 6 over and I take the square root, I get plus minus square root of 6 because he doesn't come out nicely. Holy crap. Holy crap. You know what? That might be all the farther we get today, just this problem, because this is a lot. Okay, here we go. We have a ton of things. We have 0 as a critical number. We have plus minus square root of 3 as a critical number. We have 0 again as a critical number, and we have plus minus square root of 6 as a critical number. All right, so that means that there are 3 here, 3 critical numbers here, 3 critical numbers here, but the 0 is repeated. So we have 5 critical numbers all together. Okay, I'm gonna make my table. I don't know, you could put them up. We could put them up here maybe. Yeah, let's put them right here. 5 critical numbers. Holy crap. All right. That means we have 6 test intervals. Gross. Gross, gross. Okay. Oof. All right, let's see what we got. We have, hey, quit it. You sit down and you play. You sit down and you play. All right, our first critical number, if we put those in order, this is going to go negative infinity to negative square root of 6. Then we have negative square root of 6 to negative square root of 3, negative square root of 3 to 0, 0 to positive square root of 3, and square root of 3 to the square root of 6, and square root of 6 to infinity. Holy crap. All right. Okay. Hopefully you're still with me here. You know, this is a lot. Okay, so I need a test point from negative infinity to negative square root of 6. Square root of 6 is like going to be 2 point something, right? So let's just go negative 3, okay? Between these two, this is negative 2 point something, and this is negative 1 point something. So let's just go negative 2 here. Let's go negative 1 here, positive 1, positive 2, positive 3. Okay, all right. Let's do that. We're going to plug into the first derivative. We're going to plug into the second derivative. We're going to do our conclusions. We're going to call it a day. Okay? All right. All right. Okay, our first derivative is, I think, this guy. Oh, man, that's going to be nice. First derivative. Yeah, that's going to be real nice. All right. Negative. I want to put him down over here. Negative x to the 4th. I'm just recopying him so we can see him a little bit easier. All over x to the 6th power. Okay, are you ready for this? Negative x to the 4th power. Okay, we might actually have to do some of this. But this number on the bottom, since we're taking him to the 6th power, he's always going to be positive on the bottom. So we've just got to figure out what this top number is going to be. All right, if we plug in negative 3, this will be like negative 3 to the 4th plus 3 times negative 3 squared. Okay, we do have to figure out what that top number is. Negative 3 to the 4th is 81. So this is negative 81 minus 27. No, plus 27. Okay, negative 3 squared is 9 times 3 is 27. So negative 81 plus 27, that's going to be a negative number over top of a positive number, so we're going to end up with negative. So he is decreasing. Oh, no. Let me put that down below here. He is decreasing at that point. All right. Now we got to plug in negative 2. So negative 2 to the 4th plus 3 times negative 2 squared all over. This is going to be a positive number on the bottom because it's to the 6th power, so we don't really care what it is. All right. Negative 2 to the 4th power is going to be 16. So that's negative 16. Hey. Plus sister. Come on. What? Here. There. There you go. Okay. Where am I at here? 3 times negative 2. Oh, wait. Here we go. Negative 2 squared is positive 4, so that's plus 12. Negative 16 plus 12, he's going to be negative. So that means he's decreasing again. Kason. What's up, bud? All right, come sit here. Okay, -1. -1 to the 4th. Plus 3 times -1 squared. The bottom is positive, so we don't really care about it. This is going to be -1 plus 3. So shh, you have to be quiet if you're going to be in here. So finally, we're increasing. Okay. +1 is going to be the same as -1. Actually, these will be the same, these will be the same, and these will be the same because we're taking it to the 4th power and to the 2nd power and to the 6th power, right? So like none of the signs are going to change, so it's going to end up being the same value. So this guy will be plus and these two will be minus. So he's increasing, decreasing, decreasing. Okay, so let's figure out where these points are located at and see if our graph is consistent, all right? So this guy is my square root of 6. This is negative square. Hey, shh. This is negative square root of 6. This is where the negative square root of 3 is. They did a really good job of putting those points on there, so that was kind of nice. And then here's where 0 is at. So basically, from -infinity to negative square root of 6, he's decreasing. True. From negative square root of 6 to negative square root of 3, he's decreasing. Then as soon as we hit this point, till we get to 0, he's increasing. Cool. All right. Oh, man. My kids are just deciding to, you know, like, come alive right now. Now, it's the same mirrored on the other side. So from here to here, it is increasing. True. From here to from the square root of 3 to positive square root of 6, he's decreasing. Then he's decreasing again. True. Okay. We got that. Now, we've got our second derivative, which is this guy. So we've just got to plug those numbers into that and see what we come up. Hey, shh.
Look at Navy.
I know, I see her. She's fine. Okay, x to the 12th again is not going to do anything because he's going to be positive no matter what. So we really just have to calculate the 2x to the 9th minus 12x to the 7th power. All right, do this and then we'll be done. I'm going to erase some of this stuff down below here. 2 times -3 to the 9th minus 12 times -3 to the 7th power. Oh, man. Hey, Turk, you want to go out to the kitchen out there and grab my phone? Go get it. Go get it. All right, we're going to see what we're going to get. Is he going to be concave up or concave down? I'm going to take some guesses. We're looking at this interval right here. I think he is... I don't know. Is he concave up or concave down at that point? I think he is maybe concave down-ish. I think he's going to be concave down until he gets to like here, and then he's going to switch and be concave up. I don't know. Is that a point of inflection right here? I don't know. Let's find out. Let's find out. Okay. All right, so I'm going to plug that stuff in. -3 to the 9th power. Holy crap. All right. This is not working.
Hey.
Boy, you have to be good. Okay, and then times 2. This is what? 3 to the 9th power. Times 2. Okay, this is -39,366 minus 3 to the 7th power times 12. Okay, so that will be positive 26,244. Okay, because we have 7 negatives and then another negative, which makes it a positive. Okay, this right here, if we add those two together, is going to be negative, which means he is concave down. Okay, I guessed that. I guessed that. All right, let's do a -2. So I'm going to switch these all to be -2s. If you have this in your calculator, it'd be really nice to switch it. -2 to the 9th times 2, which is kind of like doing 2 to the 10th power. This is negative. Why did you just do that? No, don't touch me with your slobber. Why did you do that? Okay. 2 to the 7th power times 12 is, and that will be a positive 1536. So these together is going to be positive. Okay, so he switches and he's concave up at this point. So here, this little bubble right here, from here to here, he's actually concave up. And this is obviously going to be concave up as well. So let's plug in -1. We're going to get a positive. He's going to be concave up, I'm sure. But let's see. So changing him to a 1 and a 1. -1 to the 9th power is -1 times 2 is -2. -1 to the 7th is going to be -1 times -12 is plus 12. So that's going to be positive concave up. Cool. All right, now, these are going to be the opposite of what they were before because we've switched the signs. So like here when we did our first derivative, these were mirrored. So these were the same. Okay, now because we're to the 7th power and to the 9th power, they're going to be exactly the opposite. Okay, so where these were pluses, these are going to be minuses now. So this is concave down. This is concave down because we're doing the same computation, but now to the 7th and 9th power. This, since he's minus, he's now going to be plus. So this is concave up. Let's see what we've got going on here. So here, concave down from here to here. This is also considered concave down. Right, it kind of looks like a straight line, but he is technically concave down. Then he starts to concave upward. So he's doing kind of one of those swoopy things at the end. Okay, holy crapola, that was a lot. And we still have to figure out what are the relative extrema. So do we have any maxes and mins? Okay, so to do maxes and mins, we look at our first derivative. So where he's switching. Right here is where he switches. So he's going downhill, then uphill. So he has a minimum there. Right? So he has I'm just going to say a minimum at -square root of 6. Min at -square root of 6, comma something. I'm not going to figure the something out because that's a lot. Then he's increasing here and then he goes to decreasing. Increasing, then decreasing. So it looks like he has a maximum there, but he actually doesn't because increasing, decreasing. Yeah. No. I'm looking at the wrong spot here. What are we doing? What are we doing? Negative, negative, negative. Okay, I'm looking at the wrong derivative. Blah, 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 blah. Get rid of that. Get rid of that. We are just a hot mess right now. Okay, I'm looking at this one right here. So he's negative here. He's negative here. So he is negative, then positive. So he's going to have a minimum at -square root of 3. That's better. Right here is my minimum. Okay, then it looks like he switches between these two, but he doesn't because that's a vertical asymptote. Okay, so now I just have to look at this switch. Now he's plus and then minus, so he's going to have a maximum at +square root of 3. Okay, then the only other thing that I have to look at is where he switches concave up, concave down. So this guy, since he's changing to minus to plus, he has a POI at -square root of 6. POI at -square root of 6. Then he switches concavity here, but this is a vertical asymptote right here. So he's not a POI there. Here he switches concavity again at +square root of 6. Holy crap. So there's all my things. Maxes, mins, POIs, all that good stuff. Gross. That was very disgusting. It wouldn't have been so bad if they would have just had us do the first derivative. But, yeah, doing the inflection points, that was ugly. Okay, I'm not going to go ahead and do example 4 like I was going to because that was a lot. So what I want you to do is number 2, I don't think you have to do as many things. Maybe it's just like, I think it's just like vertical, horizontal asymptotes and then the intercepts. I don't think you have to do any inflection points. I don't know. I could be wrong. But attempt number 2 and then try number 20 because I think that was similar to the one that we just did. But stop after the first derivative. So if they ask for POIs, don't do those yet. We'll save those for another day. All right. So skip the POIs on 20. Just do all of the other things up to the first derivative. Okay. All right. Just do those for now. 34 you can hold off on. All right. That was a lot. I hope that, look at a mess. Ugh, yuck. Gross. Okay, I'm going to leave you now. Goodbye.